Solve problem on 3 cranks of 3-cylinder locomotive. Given question: the 3 cranks of 3-cylinder locomotive are all on the same axle and are set at 120 degree. The pitch of the cylinder is 1 meter and the stroke of each piston is 0.6 meter. The reciprocating masses are 300 kg for inside cylinder and 260 kg for each outside cylinder, and the planes of rotation of the balance masses are 0.8 meter from the inside crank. If 40% of the reciprocating parts are to be balanced, find first the magnitude and the position of the balancing masses required at a radius of 0.6 meter. Second, the hammer blow per wheel when the axle makes 6 rps.
Let us understand the given data and we will draw the diagram for the position of planes as well as angular position of the masses. This is the example for the 3-cylinder and 3 crank system. Now the 3 cranks are set at 120 degree apart. So in the diagram for the angular positions we will consider 3 cranks A, B and C. So we will place here that is the angle in between crank A to B is 120, then B to C is also 120 degree, and then A to C is also equal to 120 degree. Now cylinder pitch is 1 meter. Now if we observe, this is the 3-cylinder system. So we have to draw 3 vertical lines. Now these 3 vertical lines we have to show the distance is equal to 1 meter, because cylinder pitch, that is the distance in between these 3 cylinders, is given or mentioned, that is equal to 1 meter. So I will mention here this is 1 meter and here is also 1 meter. Then stroke of each piston. So stroke of each piston is given 0.6 meter. Now we know that this stroke of piston, that means this is the reciprocating motion, and this stroke, that means when one motion is getting completed, and that is equal to 0.6 meter. Now we have to find out the crank radius. So what is the relation in between the stroke of piston as well as crank radius? So this reciprocating motion is getting converted into rotary motion. So this stroke length is equal to 2 multiplied by crank radius. So we can say that L is equal to 2R. So radius at crank, that is equal to 0.3 meter. So this is the radius. So we have to show that, because this radius of crank we have to show at the place of the cylinder. Now we know that we have considered 3 cylinders are for A, B and C. So I will mention here, this is the cylinder A, this is the cylinder B and this is the cylinder C. Now crank radius, that is the radius of rotation, we have to mention here, and that is 0.3 meter. So for each cylinder we have to place this 0.3 meter. Reciprocating masses for inside cylinder. So for the inside cylinder, reciprocating masses 300 kg. So we can say that at cylinder B, or we can say that MB is equal to 300 kg. And outside cylinder, so these are the outside cylinders, and it is equal to 260 kg each. So for each cylinder we have to mention here 260 kg. Now plane of rotation of balance masses. So here we know that the balance masses are added to the wheels. Now this is the example for the 3-cylinder and 3 crank system, and in any system there are only 2 wheels in the locomotive. So where we have to place these wheels? We have to place these wheels in between these cylinders. So here plane of rotation of balance masses. So balancing masses are provided to the wheels, and it is 0.8 meter from inside crank. So we have to mark here one point of is equal to 0.8 meter from this inside crank. So this is the inside crank and these are the outside cranks. So from this point we have to mark here one point that is equal to 0.8 meter. So I will mention here on both sides 0.8 meter, then draw here one vertical line, and these lines are for wheels. So here is the wheel 1, so W1, and this is W2, that is the wheel 2. 40% of reciprocating masses is to be balanced. So portion of mass is to be balanced, that is 40% of this 300 kilogram and for 260 kilogram. So what is the value of C? C is equal to 40 by 100, that is 0.4. So we have to write here, this is from the given data, C is equal to 0.4. Now balancing mass radius. So we know that the balancing mass is provided on the wheels. So here are the wheels. So radius, that means here we can say radius of rotation, that is equal to 0.6 meter. So this information is also mentioned. So we will write here as a 0.6 meter. Then axle speed. So here for hammer blow, axle speed is given and it is given in RPS. So axle speed is 6 RPS. Now we know that we have used the formula to calculate omega. So omega is equal to 2 pi n by 60. But here n is given in RPM. But here it is given in RPS. So we will write here the formula, omega is equal to 2 pi n. So omega is equal to 2 pi into 6, that is equal to 12 pi. So we have to calculate this by using calculator and we will find out the value of omega. All the masses at cylinder and wheel are rotating in different planes. So we will prepare table for the masses rotating in different planes to draw the force polygon as well as couple polygon. So first column is for plane. So we will take the reference of this diagram. So planes are A, then for the wheel we will give the number 1 and 2. So here A, then 1, B, 2 and C. So we have to show these planes in the same order, A, 1, B, 2 and C. Now next column is for mass. So mass at this cylinder A. So here 260 kilogram is given, but the portion of the mass which is to be balanced is equal to 40% and which is equal to 0.4. So we have to multiply with this portion. So 260 multiplied by 0.4 is equal to 104 kilogram. So for this plane A as well as plane C, we have to show the same mass, that is 104 kilogram. Then the balancing mass at wheel. So this mass is not mentioned in the question. So we have to find out. So we will write here as a M1 and for 2, that is wheel number 2, it is M2. Then the mass at cylinder B. So it is 300 kilogram. So 300 multiplied by 0.4, that is equal to 120 kilogram. Then the radius of rotation. So radius of rotation for the cylinder A, that is the crank radius 0.3 meter. Then for the wheel, so for the wheel balancing mass radius is mentioned 0.6. Then for B also it is 0.3, for 2 it is 0.6 and for C it is 0.3 meter. Then centrifugal force. So centrifugal force, that is equal to mr omega square. But all the masses are rotating with same angular velocity. So we will write here the formula F is equal to m into r. Now we have to just multiply these two columns. So 104 into 0.3, that is 31.2. Then m1 into 0.6, that is 0.6 m1. Then 120 into 0.3, 36. Then here 0.6 m2 and then last one is 31.2. Next is L. So what is this value L? That is the distance of the different planes from the reference plane. Now if we observe these different planes, then for the plane number 1 and for the plane number 2, there are unknowns m1 and m2, and that we have to find out. So we have two options to decide the reference plane. So in between 1 and 2, we can choose any one plane as a reference plane, and I will choose here this plane 1 as a reference plane. So this is the reference plane. Now we will find out the distance from this reference plane. So there are two options, that is the planes which are on the right hand side and planes which are on the left hand side. So for right hand side planes we have to use positive sign, and for the left hand side we have to use the negative sign. So first plane is A. So what is the distance in between 1 and A? So we know that here from B to A is 1 meter and from B to 1 is 0.8 meter. So remaining distance that we have to find out, that is 1 minus 0.8, that is 0.2. But because it is on the left hand side we have to write here minus 0.2. Then for 1, so it is reference plane, so it is 0. Then for B, so for B what is the distance in between these two? So it is mentioned 0.8. Then for 2, so what is the distance for the 1 to 2? So this distance we have to find out, that is 0.8 plus 0.8, that is 1.6. And for C, again for C we have to find out this 1 meter plus this 0.8, that is 1.8 meter. Now we will move for couple. So couple means this centrifugal force multiplied by this distance L. So we have to calculate this. So for plane A it is negative minus 6.24, for 1 it is 0, then 28.8, 0.96 m2, and then 56.16. So here 0.96 m2, that is the unknown term, so we will write here as with the help of red marker. Then angular position theta. So here for 3 cylinders set at 120 degree apart, and that is mentioned in the question. So here for this cylinder A, that is for A it is, we have to assume, or we have shown here, when A is placed at 0 degree, then next cylinder is placed at 120 degree, and then again next cylinder is placed 120 plus 120, that is 240 degree. So we have to write here. So this is as per the given data. Now the position for this 1 and 2 is not known. So we will find out, or we have to find out as a theta 1 and theta 2. If we observe the values for force as well as couple, then for couple there is only one unknown value, and for force there are two unknown values. So we will first draw the couple polygon with some suitable scale. So I will take here 1 centimeter is equal to 2 kilogram meter square. So with this scale, if we observe for plane A, angle is 0 degree, that means we have to draw horizontal line, and it is 6.24 kilogram meter square. So for this 6.24 kilogram meter square we have to take 3.12 centimeter. Now because of the minus sign we will show here the direction towards the left hand side. So first take one reference point, and that point is point O, and then for take scale, that is 3.12 centimeter, and direction is towards the left hand side. So next point will be small p. Now next we will move to the plane B. So for plane B its value is 28.8. So as per this scale we have to take 14.4 centimeter, and the angle is 120 degrees. So from this angular position diagram we will transfer this. And here we will show arrow, and next point will be point B. So what is the value? So we will mention value here 6.24, and here is 28.8. Now next is C. Here angle is 240 degree and value is 56.16. So for 56.16 we have to take 28.8 centimeters. So again I will make here this angle, and I will transfer this angle. So here is the end point. So we will show arrow. This point will be point C, and its value is 56.16. Now we will join these two C to O. So this, if we join these 2 points, then this couple polygon will be closed. So I will join this. Now we will show arrow also. So arrow is in this upward direction. Now what is its value? So its value is this remaining unknown 0.96 m2. Now if we observe this direction, then with this horizontal line we have to measure this angle. And now I will transfer this line as it is in the angular position diagram. So if I transfer this, then here will be this mass. Now if we refer this table, then it is for mass m2. So here mass m2 is there, and here radius is 0.6. So here this is 0.3. So we have to draw here some larger radius, and we will show here this is mass m2. If we measure this length CO, then it is 27.6 centimeters. So as per this scale, 27.6 multiplied by 2, that is 55.2 kilogram meter square. So for this value we will put this 0.96 m2, and this 0.96 m2 is equal to 55.2, and that's why m2 is equal to 57.5 kilogram. Now if we measure this angle theta 2, then it is equal to 24 degree. Now with this information, we will put this information on this fourth column. So m2 value is 57.5. So here 0.6 m2, that is 34.5, and this theta 2 is equal to 24 degree. Now we will draw here fourth polygon. So scale 1 centimeter is equal to 2 kilogram meter. So with this scale for plane A, it is 31.2. So we will take here one reference point, that is point O, and for this reference point, because of positive sign, we will draw one line towards the right hand side direction, and we will take centimeter, that is equal to 15.6 centimeter. Now it is at 0 degree, so we have to draw here horizontal line. Now we will move next. So next is for this m2. So this m2 is angle 24 degree. So at the same angle we will draw this. Now 0.6 m2, that is equal to 34.5. Now scale is 1 centimeter is equal to 2 kilogram meter. So as per this scale we will take here 17.25 centimeter. Now I will transfer the angle from this angular position diagram, and now take 17.2 centimeter and mark here one point. So here will be the next point, and for this m2 we will I will write here as a point 2, and what is the value? Value is 34.5. Now next is plane B. So for this plane B, it is 36. Now for this 36, angle is 120 degrees. So as per this scale we have to take 18 centimeter. Now angle is 120 degree. So for this 120 degree, I will take here as a 18 centimeters. So here this is the point. So here the next point is for plane B, that is I will show here as a small b. Then next is for C. So for C, again if we observe, angle is 240 degree and it is 31.2. So for 31.2 we have to take 15.6. So again at the same angle I will draw here one line. I will transfer the angle for 15.6 centimeters. So here will be next point C. Now what is its value? Its value is 31.2, and here for this 2 to B. So for B this value is 36. Now this fourth polygon should be closed. So we will join these two points, that is C to O. So in this way it is getting closed. Now what is the direction? So to close this from C to O, we have to show the direction in this way. Now we will transfer the same angle in this angular position diagram. So I will transfer this. So here, now what is the radius? So radius for this one is 0.6. So we have to show here some larger radius, and this is the mass m1. If we measure this length CO, it is 17.2 centimeter. Now we will multiply with scale, then it is 34.4 kilogram meter. So its a value is 0.6 m1. So m1 is equal to 57.5 kilogram. And theta 1. So if we measure this value from this reference plane A, then it's a 215 degree. Now the next we have to find out the hammer blow. So this hammer blow is related to balancing mass provided on the wheels, and the wheels are rotating in plane 1 as well as plane 2. So its a formula is mb/rb omega square. So what is the value of mb? So we can take here value of m1, that is 57.5 kilogram. Then RB, that is the radius of this balancing mass. So we will take the value for this R1, that is 0.6, and omega we have calculated earlier from the given data, and its a value is 37.69, and we have to take its a square. So when we solve this, then we will get the answer 49.03 into 10 raised to 3 Newton.